Okay, good evening, everybody. Today we have a guest lecture, and our guest is Dr. Hakeem-Ur-Rehman. Dr. Hakeem is an expert of statistics and business analytics. He is an expert in R programming and use of Python. And today we'll be discussing about data visualization using another package that is GGPLOT2. I hope it will be very informative for us, and I think it's especially timely because I know most of you are doing your project nowadays, and that project is mainly R based, and that project requires you to do a certain type of statistical test and certain visualizations. So although we have done it by using in basic R program, and for some of tests we have also used some libraries such as Psych, but this one is GGPLOT2, is more advanced one. And Dr. Hakeem, he will be telling us, he will be showing us different types of statistical tests and using different type of visualizations using our program. So without any further delay, I hand over to Dr. Hakeem-Ur-Rehman.
Thank you so much, Dr. Asif. So it's really a great pleasure to present data visualization, especially using the GGPLOT2 package. So what I am going to talk about, first of all, we will briefly discuss about what is the business analytics. Then I will let you know what kind of analytics we have. So which means we will talk about the types of business analytics. Then we will discuss brief examples
Recording in progress.
About the HR analytics, like we can say that the business analytics in human resource management, similarly business analytics in marketing perspective, we will see some examples as well as supply chain analytics. And then our main focus of today's lecture is going to be on data visualization using R. So I will let you know different types of packages available in R. But our focus is, as Dr. Asif told you, that is going to be GGPLOT2. Okay, so that would be our main focus. So we will see how we can display the data if we have the qualitative type of the data. If we have the quantitative of the data, how we can visualize and what kind of plots and charts are available. And then we will see how we can tell the story using a different type of plots. Telling the story, which mean I want to see the data with respect to the deviation point of view from certain point, whether I want to see certain correlations between the variables, whether I want to rank something, or whether I want to see the distribution of certain variable as well as the magnitude. So as well as I will give you some YouTube links from my YouTube channel if you are interested in order to know about the correlation and regression analysis as well as testing of hypotheses and some techniques with respect to the Python perspective. But our main focus is going to be on data visualization. But let's start what's the business analytics is. So, as you might know that business analytics is basically talking about the fact-based management. That means we have to take the decision based on facts and figures. So, being the business analytics student, so we should know about some mathematics and statistical techniques. So, we should have the knowledge of computer science. So, when we are saying the computer science, that means we are talking about in terms of analytics perspective. We should know one or two programming language, such as the most popular one are the R language as well as the Python. And we should know some database tools like SQL, and then we must have the business side knowledge, such as if I am the marketing person, so I should know the marketing problem, similarly HR, similarly operations, similarly supply chain perspective. So the domain knowledge is also very important when we are going to solve some business analytics problem. So using some analytical technique, we are trying to solve marketing, finance, HR, and supply chain related problems. So now the question is, what kind of analytics we have? So we have four types of analytics. Okay. So the first one is the descriptive analytics. The second one is the diagnostic. predictive and prescriptive. So normally when we are talking about the descriptive and the diagnostic perspective, these two, in which we are using the historical data and we are trying to understand what happened previously. So that means based on the previous data, we try to get some insights, what happened, what factors are affecting our sales, what factors are affecting our inventory, and so on. Similarly, we are trying to get some the causes behind that one. Why sale is increasing in certain region? Okay, why sale is decreasing in certain region? Okay, why we are not getting certain profit? Okay, so that means we are trying to get the answer from the historical data, what happened and why did it happen. So for that we can use different type of the techniques. Okay, so our focus is going to be that is the visualization, so which means we are trying to answer what happened and why did it happen. So in today's lecture we are talking about descriptive analytics as well as diagnostic analytics perspective. And the third thing is we have the predictive analytics. That means we are trying to predict the future. Okay, so for that we have some statistical techniques as well as we have some machine learning related techniques, such as linear regression. We have multiple regression, logistic regression, neural network, deep learning, and many more. And then once we have predict something, the next thing is we are focusing on which among the multiple alternative, which alternative is the best one. So that means we are trying to make the optimum decision. So that is the prescriptive analytics. So when we are talking about the optimum decision, so we have multiple techniques. So that is the major focus of the prescriptive analytics, that is the optimization, simulation, network science. So prescriptive analytics is heavily occupied by the subject of operations research, which is also known as OR. So as you can see that, so this prescriptive analytics is basically the decision focus, because among the multiple alternatives, we are trying to pick up the best one. Whereas in the previously, we are mainly focusing on using the historical data. We are trying to identify what happened, why did it happen, or what will happen. So that means we are trying to predicting something. But as I told you earlier, so the focus of today's lecture is going to be on descriptive as well as the diagnostic analytics. Okay. So if we see the analytics in terms of the HR, so here I am giving you the example. So even Google is using the analytics and they call it HR analytics. By calling HR analytics, so they are basically focusing on talking about the people analytics terminology. And they are using these analytics in order to identify the characteristics of the leaders. So they are using the analytics in order to identify the factors that are contributing towards the productivity. So they are evaluating the potential of new hires. Okay. Similarly, they are using the predictive analytics to forecast or to predict the turnover rate or retention time of your employees. So here I'm giving the two websites. So in these websites, you can find out the multiple data sets from the different domain, especially the HR data. From this website, you will find out approximately 20 to 21 data sources related to the HR field. Okay, but whereas from the kaggle.com you can find out the data set from different domains, even from healthcare, energy, supply chain, marketing, HR. So different fields related data you will find out. So this is one of the most famous website for data scientists, for machine learning engineers, as well as business analytics persons. Okay, so similarly, we can talk about that analytics helps to the marketing persons in order to segment the customers, in order to betterly understanding the behavior of the customer. So, however, we would be able to advertise the budget properly. Okay, we should effectively get the pricing strategies. We would be able to improve the forecasting demand. Okay, so that means marketing analytics telling us different marketing programs. We can compare them and then we can identify which marketing program is more appropriate or the best one in terms of return on investment, in terms of overall marketing effectiveness perspective. Okay. Similarly, we can use the analytics even in the domain of supply chain as well. So I have taken these two pictures from this particular article, which is very good article. So over here you can see that they are mentioning the SCORE model, which is basically sourcing, procurement, operational research, reference model, in which you can say that we have the four main areas which are important in terms of the supply chain, which is sourcing, making, delivery, and return. So in every particular domain, what kind of activities we can perform, okay, and then these are the decision levels, whether we are doing the strategic decisions, whether we are doing the tactical decisions or the operational decisions, okay, and obviously all these decisions are based on planning. So over here, I'm mentioning certain tasks. So which in the supply chain, as a supply chain person at a strategic level, what kind of things we are doing? Okay, at a make level, what kind of things we are doing? So certain examples you can see over here. And for that, we have different types of analytics in order to make the good decision. So which means if I'm giving the example of product line mix at a particular plant, so that means what kind of product we are going to produce in a certain plant. Okay, so what should be the mix of product? If we are producing 10 type of product, so how much quantity we should produce of product A, how much quantity of product we should produce on a product line 2, and so on. So for that, we have the multiple analytical techniques such as descriptive analytics techniques, predictive analytic techniques, as well as the prescriptive analytic techniques. Okay, so as you can see that using different analytical techniques such as descriptive, such as predictive, as well as the prescriptive analytics. Okay, as I told you earlier, so prescriptive analytics is heavily occupied by the operation research, which is also known as the management science. So here are the list of techniques which are available in the prescriptive analytics, list of techniques available in the predictive and the descriptive analytics perspective. So in the domain of, which mean in the domain of supply chain or HR or healthcare or finance. So we can apply analytics in every domain to perform certain tasks. So whether we want to measure the sales for effectiveness, whether we want to analyze the campaign and promotions, okay, whether we want to segment the customer in terms of marketing perspective, whether we want to predict the forecasting. So depending upon the particular task, so we are going to pick a particular analytical technique. So the major important point is based on the task, we are trying to identify what kind of questions answer we are going to give, whether we are interested to find out what happened, or whether we are interested in why did it happen, or whether we are interested what will happen, okay, or what should we do. So depending upon our question on the particular task, we are going to pick up the techniques. So as I told you earlier, if we are interested in to find out what happened or why did it happen, so that means we are talking about the descriptive analytical techniques, okay, okay, as well as the diagnostic techniques. So if we are interested in what will happen, so that means we are interested in the predictive analytical techniques. So if we are interested in what should we do, so that means we are talking about the decision making perspective. That means we are talking about the prescriptive analytical techniques. Okay, as we talked about earlier, so our main focus of the today's lecture is the data visualization, which is very important topic, especially for the business users, in order to understand the data and as well as in order to understand the your particular business problem. So in R, we have the multiple type of packages available for the data visualizations. So we have GGPLOT2, which we are going to discuss today in detail. Okay, we have GGVIS and so on. Okay, we have Plotly is also a very good package. Okay, so so in order to install GGPLOT2, so we can do two things. Either we can directly install the GGPLOT2, or either we can use tidyverse. So because in this tidyverse, they have incorporated GGPLOT2. So once you install the tidyverse package, so GGPLOT2 automatically installed. But you can also install them separately. So for this particular package, these two books are very good books. Okay, so actually this guy he introduced this particular package, and then after that this guy explained this particular package. So these two books are very good books for the ggplot2 package. Okay, now the question is ggplot means what? So that means this GG stands for grammar of graphics, okay, which is come from the first book which I told you earlier. So ggplot2 package in a Plotted package. So we have a function called whenever we want to draw a certain graph. So we can use a function that is called as ggplot. So this ggplot function has multiple, you can say, objects. The first one, in order to draw a simple graph package, we need three important components. One is the data. So how you can represent the data in a ggplot? So we are using a function called ggplot, and then we will mention a variable in which we have stored the data set. The second thing, once we have mentioning a variable in which we have a data set, the second thing we have to mention about the statics mapping. That means we should talk about what is going to be on x-axis, what is going to be on y-axis, okay, what color we are going to fill, different types of bars, what kind of lines we want to draw, what should be the size of those bars or the points. Okay, so which mean once we mention this axis, okay, or you can say statics of the mapping, the third thing we need to mention is the type of the plot. Okay, that means we are talking about the geometric object, whether we are want to draw a simple bar chart, or whether we want to draw a pie chart or a histogram or box plot or a violin plot. So we have to mention the type of the plot. So in addition to these three objects in a ggplot2, so which we talk about this one. So as I told you earlier, so in data we have the data set. Okay, in that particular variable statics x-axis, geometric we have the different types of graphs, and then we have these components which are optional. So depending upon how you can visualize your data set. Okay, so basically in a facets you can mention, you can break the plots in the small pieces. Okay, either column wise you can break it, or either you can row wise you can break it. Okay, similarly if you are interested to show some statistics on the graph, such as average, standard deviation, standard errors, confidence intervals, so then you can add this statistics object. Similarly if you want to do some you can say additions in the coordinates, okay, so you can also use this particular object. Similarly we have different type of themes, like especially in order to you can say change the background colors of the graphs. Okay, so we have the different type of built-in themes in this ggplot2. So using these 7 to 8 objects in a ggplot2, we can draw a very good visualization graphs. Okay, so now let's discuss first of all, if we have a qualitative type of the data, how we can visualize this type of the data. So first of all, what is the definition of the qualitative data is that which we cannot measure. We can only, you can say, count it, okay, or we can classify it. Such as if I am saying gender would be your qualitative type of the data. Countries, okay, countries could be your qualitative type of the data. National id card numbers, okay, could be your qualitative type of data, which we can only use to classify the things. So in a qualitative data, normally we have two types of scale. One is nominal, okay, and other one is the ordinal scale, right? So nominal is just to categorize the things such as male, female, such as the countries USA, UK, okay, Australia. So these are just to classify the things. Name of the students, name of the universities are the nominal scales. Whereas in an ordinal scale, classification is there, but we can also rank them, such as very good, okay, good, and poor. So now we can rank them. So this is greater than, this is greater than. So which means very good is having the higher rank compared to the good. Similarly, good having the higher rank compared to the poor. So we can rank them. So normally, whenever we are talking about the qualitative type of the data, mostly our data set is going to be on a nominal and a ordinal scale. Now the question is, in order to visualize this type of the data, we have multiple type of charts such as bar chart, pie chart, multiple bar chart, component chart, or even we can also use line plots. Okay. So first of all, we have a different type of bar chart. So normally when we are saying bar chart, we are talking about the simple bar chart. So when we are saying simple bar chart, that means we are talking about a one factor at a time perspective. Okay. So one factor mean we are talking about in a tabular form perspective, one way table. Okay. Similarly, if we are going to talk about the pie chart, we can also use the pie chart as a visualization technique when we have one factor. Okay, but when we have more than one factor, so in terms of tabular, we can use either two-way table, three-way table, or n-way, depending upon the number of factors. If we have two factors, we can use two-way table, okay, in order to show the data set in a tabular form. If we have three factors, we can use three-way tables, and so on. Okay, so whenever we have two-way or more than two-way tables, that means whenever we have two factors or more than two factors, so either we can use the multiple bar chart, or which is also known as side-by-side bar chart, or either we can use component bar chart. Okay, so let me open R programming language. If you can also open it, so I will explain to you under what situation we can apply the simple bar chart, under what situation we can apply the pie chart, okay, with the help of this particular example. Okay, similarly, multiple bar chart, component bar chart. So for that, basically, if you open this R code, from this R code, I am using a data set which is called as the employer data. Okay, so this employer data, if I open it, so how can I read it? Because this data set is available in a CSV format. So I am using a function called read.csv. Okay, then I am in this particular function, I am writing down another function which is called as file.choose. So with the help of this particular function, there will be a pop-up menu, okay, which I can use to pick up the data file wherever I have in my computer. So with the help of this header is equal to true, what will happen? So in the data set, the first row is going to be chosen as the name of the variables. So if I run it, okay, so as you can see that I have a window, okay. In this particular window, I can pick up the data set. So wherever I have the data set, so you can go to that particular folder. So right now I have the data set in the employee database.csv. So with the help of this view function, I can visualize, or you can say I can check this data set. So basically, in this particular data set, we have 7 or 8 columns. We have ID, we have gender, we have birth date of the employees, education level of the employees, job categories, salary, okay, current salary, or you can say salary at the beginning stage, okay, job times, okay, previous experience, okay, whether it's minority or the majority, you can say factor. Okay, now so first of all, if I am going to talk about in terms of the qualitative perspective, so gender is going to be your qualitative and in a nominal scale. Okay, whereas your birth date can be considered normally if we are writing over in this perspective. This is can be considered as a qualitative because every person having a unique birth date. Okay, education, although we are mentioning in a numerical perspective, but it should be considered as a factor, or you can say as a qualitative data. So whether the person having the education level 15 year or a 16 year or a 12 years. So job category is also a qualitative. So we have the quantitative variable is the salary at beginning, or maybe the job experience. Okay, so that can be considered as the quantitative variables. But first of all, we have some very useful functions in R. You might know the function of head. So by using this, we can check the first six row entries in our data set in order to check the missing values in our data. Okay, or you can say any you can say any confusion in your data, so you can visualize with the help of this head. So if you are interested to see the last six data rows, so you can use the function called tail. Okay, so with the help of this tail function, you can check the last six rows. But if you are interested to check the first 10 rows, so you can just mention comma 10, and then you can check the first 10 rows data entries. Okay, so it's up to you whether you want to use the default rows, or whether you want to use the particular number of rows. Okay, then another function which is very important, that is called as the class. And then I am using the name of the variable in which we have a data set. So if I run this command, I can see the class of this variable, which means that is called as the data frame. So remember that whenever we are dealing with the data set, it should be the data frame, especially for the ggplot2 package, because in R we have multiple type of the data, you can say data sets, could be which is also known as data structures, which is list, we have matrices, we have arrays, we have the data frame. So in data frame, how you can define it, such type of data which have the mix of variables. Okay, like some of them are the qualitative, some of them are the quantitative. Such sort of the data would be in our language known as the data frame. Okay, now we are talking about once we have read the data. Okay, now we are want to see the information related to this data set. So that means I am interested in order to know about the structure of the data. So I can use the function of str, which is basically the structure, and then the name of the variable in which we have data. If I run it, so now R is telling us that ID it is considering as integer. So when R is mentioning integer, that means it is considering as a quantitative variable. When R is mentioning CHR, which means character, okay, that means it is considering as a qualitative data, or you can say as a factor. Similarly, right now, as you can see that education R is considering as a numerical data, as a quantitative data. Okay, similarly, job category is a qualitative type of data. So this function is very important in order to get some information about every particular variable in your data set. Now the next thing is I want to access particular variable. So how can I access? There are three methods to access the particular column. Like I want to see this particular column, which is a gender. So how can I do that? I can simply write down the name of the variable, and then using the dollar sign, I can pick that particular variable. Okay, if I run it, now you can see that I can only check the data against that particular variable. Similarly, the second way is I can use this approach, okay, which is basically you can say list, and in the list I am mentioning the name of the variable, so which is basically the gender variable. Okay, so either we can do this one. Okay, and the third one is I can mention the position of the column. So remember that the first one is the row and the second one is the column. So right now the gender column on a second position. So we can mention comma 2. So that means I can access the second column. Okay. So there is a three way to access a particular column. Okay. So similarly, I'm using the head and then I'm using this particular command in order to check the first 6 rows data entry. So we can see that the first is the male, the second is male, female, and so on. Okay. Now, in order to access the multiple columns, what we can do, I'm using the name of the variable. Then we can start the braces, okay, and then comma. So I'm mentioning 2:4. So which means it must show me the second column, the third column, and the fourth column, which is gender, birth date, and education. So if I run this particular command, so I can see only the three columns from my data set, which is basically related to the gender, okay, birth date, and the education. Okay, so if I want to access a column of ID, I want to access the column of birth date, okay, as well as the job category, because the first three column I want to access, which is ID, gender, birth date, they are consecutive, but the next thing I want to access from the job category. So how can I do that? I can use concatenate function. This C means that is a concatenate function, and then using one colon sign 3. Okay, so now I can access the first column, the second column, and the third column. Okay, and then we are mentioning comma 5. So that means on a fifth column, whatever the column variable is, so we can access that one too. So if I run it, so I can see the column number 1. So that means that is ID. I can see the second variable, which is gender. I can see the third variable, and I can see the fifth variable, which is the job category. Okay, that is the fifth one. So this is the how you can access the particular columns. Okay, now, if I want to know the name of the variable, so I can use the function called as column name. Okay, so if I run this one, so I can see that the name of the first variable is ID, the second name of the variable is gender, birth date, education, and so on. Okay, so till now we have discussed how we can access the particular column. So if I want to access the particular row, how can I do that? So if right now I am interested to check the first row data entry. So we can write on 1, comma, so on. So that means it will show me the first row and all the columns data. Okay, if I want to access the 100th row, okay, if I want to access the row 1 data entry, row 4th, and row 7th data entry, so how can I do that? So this is row 1, row 2, row 4, and row 7 data entry. Now, if I want to access the particular element from our data set, like I want to extract fourth row and fifth column data entry. Okay, so that means if I run it, I can see clerical. So that means fourth row, okay, and the fifth column, which is the job category, we can see that this is basically the clerical, right? This is the clerical data entry. We can see that. Now, in addition to accessing the particular columns, rows, now if I want to access the data set, or you can say subset the data with the help of certain condition, like I want to access my data from my data set, the persons having the gender male and having the education level 19. So for that, I can use the function called which. So how we can do that? I am first of all writing down the name of the variable in which we have the data set. Then I am writing down calling a function which is which. Then I am saying that from the employee data, that is the name of the variable in which we have a data set, dollar sign, we are accessing the name of the variable which is gender, and then I am saying equal to. So when we are saying equal to, so this is basically 2 times equal, because in R we have single equal is using as an assignment operator. So there are two types of assignment operator in R. Either you can use equal or either you can use less than and minus sign. So these two symbols can be used as the assignment operators. Okay, if you want to assign some certain thing to a particular variable, as we were doing over here. Okay, as we have assigned this entire data frame to the variable called implied data using this particular assignment operator. So either we can use this one or either we can use equal to sign. So it's up to you, whatever the sign you want to use it. But if I want to see the equal, so that means I have to mention 2 times, okay, equal sign, then male. So right now I am saying in the gender column of the employee data, wherever there is a male, and then I am saying and their education must be greater than 19. So show me the data set. Okay, so if we run this one, so we can see that we can only check the data set having the in a gender column we have male and their education level is more than 19 years of qualification. Similarly, if I want to access the females, and they have the job category is the manager. Okay, so how we can do that? Simply using the which function, name of the variable, and then we are mentioning it should be equal to female, and then job category equal to manager. So if we can run this command, we can access or you can say subset the data, and we can see that only the females and having the job category is gender. So this is the and sign, which means the meaning of this and sign is these two conditions must met. So there is another symbol which we can use, that is the pipe symbol, which is also known as a OR symbol. So what this meaning is, if one of the condition is satisfied, show me the data set. Okay, so which means if one of the condition is satisfied, it will show us the data set. So that means either the male or having the education level 19 years. So if any of the condition is satisfied, it will show us the data set. Okay, so if we are going to apply and, so that means both the condition must be satisfied, then show us the data. Okay, now if you remember when we run this command, the structure, as you can see that the education data type is the integer, which means R is considering this particular variable as a numerical variable. So if you want to convert this education variable into a factor, which means into a qualitative variable, so how you can do that? So we can use, first of all, I am checking again the class of this particular variable, which is integer, which we can also check with the help of structure function. Now, I can, in order to convert this particular variable into a factor, I can use a function called as dot factor and then name of the variable. Okay, so once I am using this particular function, now I am storing this variable into the called employee data dollar sign education. So now if I run it, and again I can access this, check the class of this particular variable. If now if I can check it, as you can see that the first of all it was integer, now it is in a factor form. So this is the way you can convert any particular integer into the factor. Okay, so I hope it's clear till now. Till now we were talking about just briefly about the introduction to the R programming language. So how you can access the particular data set, how you can access the columns, how you can access the rows, how you can access the particular element. Similarly, how you can subset the data set by applying certain conditions, as well as how we can convert a numerical type or an integer type of variable into the factor. Now we are going towards the visualization and data visualization using the ggplot2. So as I mentioned earlier, So in order to use the ggplot2, either I can first of all install this package. So I hope you know how to do that. So you can use two way, either you can just mention install dot package, okay, and then you can mention the name of the package over here, which is ggplot2, or either we can use from the RStudio this package install, okay, and then there will be a bar and then you can search that package, okay. So right now I can mention over here ggplot2, okay. So once written down the ggplot2, you can click on the install button and the ggplot is going to be installed, okay. But I have already installed this ggplot, so I am just calling it with the help of library function, okay. So either you can use this one, or as I told you earlier, either you can use tidyverse package. So with the help of tidyverse package, it will install ggplot2 package, okay. So now, I mean, it will call us. Now the question is, we have the data set of the employer data. So I want to know how many male are working in this particular company and how many female are working in this particular company. If I back to my this particular slide, which we were talking about. So right now, I'm talking about only a single factor, which is gender. Okay, and with the help of gender, I want to know how many male are working in this particular organization, how many female are working in this organization. So which means we are talking about one way table. So that means we are talking about only a single factor. So that means this table is going to be how many male and how many female are working in this particular organization. So we can see their frequency. So how we can do that in R? So I can use the function called table, okay, and then name of the variable. So if I run it, so you can see the frequency of male and female. Okay, so we can start. Okay, I can start from the box plot.
Yes, thank you, Dr. Hakim. Actually, in bar plot, many of our students they are already using this box plot to make some visualization,
Okay,
and they are using in basic R version,
okay,
and basic R version is not that much informative.
okay.
So I hope this ggplot2 version that would be more informative, especially when it comes to labeling.
Yes, yes, it is. So what I'm going to do is I will quickly run every particular command, uh, but I'm going to explain the box plot in detail. Is it okay? However, they should be able to understand the syntax of the ggplot2 function.
Yeah, yes, that's fine.
Okay, okay. So now if I want to draw a simple bar chart using the ggplot2, so what we need to do is I'm calling a function ggplot, then name of the variable in which we have a data set. Because it's a single factor, so that means we only need to mention the x-axis, which is the static function, which is AES, x is equal to gender, and then with the help of this plus means we are adding a object. So what type of object we are adding, that is the type of the plot, which is uh, a bar plot, okay. So if I run it, so we can see that this is the bar chart, and here we can see the frequency. Similarly, as I mentioned earlier, the rest of the things are the optional, such as I mentioned, the theme, statistics, coordinate, and facets. Okay, so right now, if I want to dark this theme, so I can use theme underscore dark, as well as I can label this plot. Okay, so if I run it, you can see that the theme is going to be changed. X-axis we are labeled gender, y-axis that is basically employee count, and the title of the graph is gender-wise employee. Okay, so similarly, if I want to draw a multiple bar chart, okay, so on a x-axis we have a gender, and then I am filling those bars with the help of the job category. So basically, I want to draw a side by side bar chart or the multiple bar chart. So how we can do that? In a GOM underscore bar, we have to mention position is equal to dodge. Okay, so the rest of the thing are the same. So if I run it, so I can see on x-axis we have gender. The bar colors are with the help of the fill, which is the job category variable, and I can see the employee counts. So if you want to draw, instead of side by side bar chart, you want to draw a stack bar chart. So then there is no need to mention over here position is equal to dodge. It should be empty. But you have to mention fill job category. So if I run it, so this is the you can say component bar chart or a stack bar chart. Now the one more important thing which I want to show is, if you want to see the quantitative variable on the y-axis, that means I want to see the average salary wise bar chart. So then how we can do that? So I am mentioning on x-axis job category, on y-axis I am mentioning salary. Okay, and then I am adding a function. So that means this plot is going to be saved in a bar variable. Okay, and then I am saying that bar plus. So this function, by using this function, I am adding the statistical function which is mean. So that means it is going to show me the average of the salary. And then I am saying draw a bar chart filled with the white color. Okay, so this is simply showing me the averages. And then I am also adding another thing is, which is basically mean confidence interval with the help of normal distribution. So that means how can I show the confidence intervals? That is with the help of error bars. Okay, so if I run this particular command, so I can see that so this is going to be, on x-axis we have the job category, on y-axis we have the salary, and the more important, this is the average salaries. Okay, so this bar length is basically indicating the average salaries, whereas these lines are indicating the error bars. So this is the upper confidence limit, this is the lower confidence limit, and this is the average value. Okay, so this one is the important one. Now I am moving towards another thing, this one. What is this one? This is basically, I want to show on x-axis the education level, but make sure whatever you are going to represent on the x-axis, it should be the factor type. It should be the qualitative. As if you remember, we have already converted this education variable into the factor. Okay, and I am filling this with the help of job category, and then with the help of this facet underscore wrap, then tilde sign gender. So what I am doing is I am breaking a graph into two, uh, you can say two portions. The first portion is going to be for male, another portion is going to be for female. Okay, so if we run this one, so this is female, male. Okay, and then each bar color is representing with the job category. On axis we can see the education. So this is count perspective. Now, I hope this is clear in terms of these charts, especially the bar charts. Okay, so I didn't show you the pie chart. Let me show you the pie chart. So which is not different, but if you use, instead of bar, you can use the pie word, and then you can draw the pie chart as well. Let me check if I have. Okay, so that maybe we can check next. So let me show you the histogram. So normally, similarly like the qualitative data, for the quantitative data, we can also visualize the graphs. So for the quantitative data, we have the histogram, we have the box and whiskers plot, or you can say box plot, and we also have the violin plot. Okay, these graphs are very important in order to know what kind of numbers we can use, which means, for this particular data, whether I should calculate mean in order to identify the center point of the data, whether I should calculate median in order to quantify the center of the data or mod. Okay, so that we, based on these data sets, I can quantify or I can identify the certain measure of center tendency. I can identify the certain measure of variation. Should I calculate for the particular data range or IQR in order to know the variation as well as the distribution of the data? So basically histograms, box plot, Violin plot tells us about the distribution of the data as well as telling us about is there any outlier in our data set. Okay. So with the help of these graphs, we can answer about the average values as well as the variation in the data as well as the distribution in the data. So how you can draw the histogram? So as we know that histogram can be drawn for the quantitative data, so that's why on x-axis I'm mentioning the quantitative variable which is salary. Okay, and then I'm using a plot which is basically the histogram. Okay, that is GOM underscore histogram, and then I am mentioning the bin width. So bin width means the width of every particular bar. Okay, the rest of the things are similar to the bar chart. Like if I am mentioning, want to mention the y-axis label, okay, x-axis label as well as the title of the graph. So if I run this one, so this is a histogram. Okay, now as you can see that the shape of this histogram is look like a positive skewed curve. So that's why we are interested about the shape of the data, because based on the shape of the data, we can, as I mentioned earlier, we can pick the appropriate measure of center tendency, we can pick the measure of variation. So if the shape of the histogram is a symmetrical curve, then in order to quantify the center point, we should calculate mean value. So that means that is a simple average. Why the mean value? Because by nature it is a mathematical average, and this is the only average basically which use entire information, or you can say entire data set. And in this particular scenario, in order to know the variation in the data, we should quantify the standard deviation. Okay, so in order to know that dispersion in the data, in order to know the variation in the data, instead of variance. So remember that there is a difference in the variance and the standard deviation. Variance always give you the answer in terms of unit scale. So if our variable is, let's say, having the unit kg, so variance is going to show us the variation in kg square, whereas standard deviation is going to give us the answer in that particular unit. So that's why whenever there is a distribution of symmetrical, so in order to quantify the center point, we have to calculate the mean value. In order to identify the variation, we have to quantify the standard deviation in order to tell the dispersion in the data. But if the shape is the positive skewed, okay, like this one, mean when the right tail is longer, which is the positive skewed curve, okay, or you can say right skewed, or either we have a left skewed, okay, or you can say negative skewed. So in this particular case, the center point, in order to know the average point, we have to calculate the median value. Okay, why median? Because in median we are not using the actual data set, basically we are using the position of the data. So that's why the median is always telling us about the 50th position, that means exactly centered position of your data. Okay, plus in order to know the variation in the data set, we have to calculate IQR, which is interquartile range. Okay, this interquartile range is basically ignoring the outer 50% of the data. It is only using the centered 50% of the data in order to tell us the variation in the data, because the formula of the IQR is third quartile minus first quartile. Okay, so third quartile means above 70, above 25% data we have ignored. Q1 means the bottom side of the 25% data we have ignored. We are using only the centered 50% of the data in order to quantify the variation of the data. So if the data shape is positive skewed or the negative skewed, in order to quantify the center point, we have to calculate median in order to know the distribution or you can say the variation in the data, so we have to quantify the interquartile range. Whereas if the shape is the type of bi-model or a tri-model, okay, in this particular case, in order to quantify the average, we should go for the mod average. Okay, okay, so because in a single data set we may have two or more than two mods, or it might be we may have no mod, because the definition of the mod is the most repeated number. And in order to quantify the variation in the data, we should quantify the range, that is basically the largest value minus the smallest value. Okay, so remember that. So that's why whenever we are talking about the quantitative data, the shape of the data is very important. So with the help of histogram, we can quantify the shape of the data, which is basically whether it is a symmetrical curve, okay, or a bell curve, whether it is a positive skewed or a negative skewed, or whether it is a bi-model. Based on those shapes, we can pick the measure of center tendency, we can pick the measure of variations. Okay, now, in addition to the histogram, so instead of using bar charts, we can also draw a polygon, frequency polygon. So the rest of the things are going to be same. Only instead of using a function histogram, we can use frequency poly. Okay, and then if I run it, so you can see that this is going to be your frequency polygon. We can also check the shape of the data even with the help of frequency polygon. In addition to using the histogram as well as the frequency polygon, we have another plot which is called as the box plot. So now instead of using histogram, now I am mentioning box plot. The rest of the things are the same. So if I run it, so now I can see this box plot. Okay, so this is basically the average value. Okay, if I can explain to you. So in a box plot, we have uh, five numbers information. So this is known as you can say lower whisker. Okay, this is known as lower whisker, which is going to be calculated with the help of the value of Q1 minus 1.5 multiplied by IQR. This is the value of Q1, this is the value of Q2, this is the value of Q3, and this is the upper whisker, which is going to be calculated with the help of Q3 plus 1.5 into IQR. Okay, so the height of this box is going to represent the variation in the data. So that's why we are saying the IQR is going to be equal to Q3 minus Q1. So this height is also representing the value of IQR, whereas Q2 is basically equal to median, okay, which is basically the center point of the data. So even with the help of box plot, you can tell whether the distribution is look like a symmetrical distribution or a skewed. If the value of Q2 lying exactly center of this box, then we can say that the shape of the distribution is symmetrical. But if the value of Q2 is near towards the Q1, then the shape of the distribution is going to be positive skewed. If the value of Q2 is near to the Q3, then the shape of the distribution is going to be negative skewed. In addition to that, we can also check the outlier in data set. So whatever the value, if it is crossing this upper whisker value or the lower whisker value, you can see stars. So those stars are basically representing the outlier in your data set. So as we can see over here, okay, with the help of these dots, so these are indicating the outliers. But if you can see the y-axis, which is the salary, so here it is mentioning us the r is a scientific notation. So if you want to remove this scientific notation, then you can use this function. Okay, if I run it and then after that I run this graph plot, now you can see that the scientific notations are removed. Okay, uh, so over here we have seen the histogram, that is was the overall salary. So if I want to know the histogram with respect to the gender, so that means male and females histogram are showing must be shown in different colors. So the rest of the things are the same, only I am adding this fill object. So if I run it, now you can see that so this pink color is basically indicating the distribution of the female salary, as well as this is with respect to the male perspective. Okay. Similarly, if you want to draw the box plot, okay, but not only we want to draw the box plot, but we also want to know the median point of the data point, mean the average point, and we are mentioning the size of that dot, as well as we are mentioning the color of that dot. Okay, so if I run it, so this is the box plot with respect to gender as well as the salary perspective. Now we can see that the average salary of the female and the average salary of the male. Whenever you want to compare certain factor against a quantitative variable, I would recommend go for the box plot or either go for the Violin plot instead of using histogram. Whenever you want to compare certain things, as you can see from this particular graph, if I want to compare which particular gender is getting more salary compared to other, so this is the very good plot compared to the histogram. So we can easily tell that male are getting more salary, average salary compared to the female. Okay, as well as the height of the box is telling us the variation in the data. So we can also see from the male box plot, which is much wider on the upper side. So that means more males are getting more salary compared to the female, and most of the female are getting almost similar type of salary instead of these females. Okay, so they may have the a higher rank job category at a managerial level they are working. Okay, so in addition to box plot, we have another plot which is a very good plot, which is basically the Violin plot. So how it is look like, so let me run. So instead of using box plot, the rest of the thing is same, we are using Violin function. So if I run it, so this is the Violin plot. Okay, but in addition to before interpreting the Violin plot, let me add another thing is, so first of all I am rotating this Violin plot. How can I rotate? By adding this function which is a coordinate. So I am saying that instead of showing me vertically, it show me horizontally. So let me run this one, so I can you can say change the coordinates. Okay, now if I want to add some statistics such as the mean value in this Violin plot, okay, so I can use the function stat underscore summary, and then I can use function is equal to mean. Okay, if I run it, now I can see this average value. Okay, now this function, with the help of this function, what I am doing is I am basically adding two plots in one thing. Normally Violin plot has two graphs. One is the box plot, okay, another is Violin. So what is Violin, I will explain in a minute. So if I run it, this is the proper Violin plot function. As you can see that the inside of this Violin plot, we have a box and whisker plot. Okay, over here, this is the basically the density of the data. So you can see that the Violin plot having two things. One is the box plot, another is the distribution of the data. Okay, so it will show us whatever the distribution of the left hand side, it would be the similar kind of the distribution is going to be on the bottom side or the left hand side. Okay, that is basically the density plot. Okay, which is basically indicating the overall distribution of the data. As we can see that this is indicating the peak of the data. So most of the data set is lying over here. So that means the average salary of the female. Similarly, as we can see that this is the average salary of the female, we can see the peak. Okay, right? And this is basically the outliers. So I hope it's clear about the box plot as well as the Violin plot as well as histogram and frequency polygon. Okay, So this was how we can draw the histogram, box and whisker plot, and the Violin plot. Now I am moving towards the different type of the data visualization stories. So basically, that is basically first of all, I am going to draw a line plot, as I mentioned earlier, that we can use the line plot whenever you want to track the plot with respect to the change over time. So that means if you want to draw a variable of time series, okay, and whatever the data which is changing over the time, so you can use the line plot. But if you have the smaller changes in your variable, so instead of using bar chart, you can also use the line plot as well. Like for that, I'm using a data set which is a built-in data set of the oranges in order to draw the line chart. And first of all, let's see the data. So with the help of view function, I am calling the data which is orange, and this has three variable. One is tree, that is the type of tree, so which is basically the five type of tree, and then age of the tree and circumference of the tree. Okay, now what I want to do is I want to draw a line plot with respect to the age of the tree, and then with the help of over the circumference, okay, and then the color of the tree. Okay, so right now we have the two, you can say the quantitative type of variable, and one we can say that the qualitative type, which is basically the tree, the type of tree. If I run this particular command, now you can see that on x-axis we have the age of the tree, on y-axis we have circumference, okay, and whereas the different type of the tree are representing with the help of different colors, okay. But let's see, if I want to remove tree number 1 and tree number 5, and I want to see only the result of tree 2, 3 and 4. So how you can do that? You can apply this filter, and the rest of the function is going to be same. So if I run this one, now you can see that there is no 1 and 5th trees plot. So only we can see the plot of tree number 2, 3 and 4. Okay, now I am moving towards the data stories perspective, like especially if you want to show the deviation in your data. Okay, so when I am saying the deviation or the variation from a certain point, okay, most of the time whenever we are draw the deviation perspective, so that means the target value we are considering is 0, but you can also set certain point as well. Okay, so that means some of the data point are going to be above the 0 point, that is a reference point. Some of the data points are below the 0 point. So for that we can plot either the type of the bar chart which is known as diverging bar chart, either we can use diverging dot plot, or either we can use lollipop chart. Okay, that is a diverging lollipop chart. So basically the basic objective of all three plots are the same. So that means that objective is to, from the reference point, we want to see the data points are above that reference point and below that reference point. Okay, so for that, basically, I'm again using a built-in data, which is empty cars data. So if I run this data set, and then I am calling that empty cars, so I can check this data set, which is basically the different type of cars we have, and then we have the different types of variable, which is mileage per gallon and the type of cylinder, then horsepower and so on. So these are the different type of variables we have. So right now I am interested with respect to the mileage per gallon. So I want to know on average which cars are covering more mileage per gallon, okay, compared to the others. Okay, so for that I'm using a divergent type of bar chart. So for that, first of all, what I am going to do is I am going to calculate the reference point. And what would be the reference point? That would be 0. Okay. Okay, so how we can calculate that one? That is with the help of that reference point, which is basically the 0, I am going to calculate the z score of the variable, which is mpg, that is mileage per gallon. So the formula of z score is going to be mpg, that is the variable, okay, minus the mean of this variable divided by the standard deviation of this particular variable. Okay, so the interpretation of the z-score is the number of standard deviation your particular data point is lying away from your mean value. Okay, so with the help of this z-score we can calculate the center point, or you can say the reference point, which is going to be 0. Okay, so how we can do that? So first of all, in a R code, what I am doing is I am first of all creating a column in order to draw the divergent bar chart. I'm creating a new column with the name of the cars, which is basically that is the name of the cars. So I am creating a column now. If I am again calling that data set, as you can see that there is a column with the name of car names. That is exactly the name of the cars. Okay. Now I am calculating the z-score. So how we can do that? So I'm using a function round. So with the help of round function, I can round it up to 2 decimal places. Then I am calling the variable, which is empty cars, that is the name of the variable in which we have the data set. And from empty cars I am accessing a column which is mpg. Okay, that is the name of the variable, minus we are calculating the mean value, and then we are calculating the standard deviation with the help of sd function. So if I run it, and then if I know, if I want to visualize this graph, so with the help of this variable, which is empty card $mpg, so it is going to be add another column with the name of mpg underscore z, and that variable we can see in our data set, which is mpgz. So this is the z score of Mazda RX. Okay, similarly we have Mazda RX WAG and so on. So these are the z scores. Okay, so as you can see that some of the z scores are positive, some of them are negative. So that mean our mean point, or you can say our reference point, is going to be 0. Now what I am doing is, now I am classifying them, which car is going to be above the referencing point, which are going to be lower the referencing point. So for that I am using a function called if else. I am saying that if this particular variable is going to be less than 0, so write down below the average, otherwise it should be above the average. So if I run it, and again run it, now you can see that they have mentioned another type of the variable, which is mg underscore type, that is with the help of this command. Okay, and it is mentioning if the value of mpg underscore z is greater than 0, it is mentioning above, it is negative, then it is mentioning below. Okay, now we are ordering this data set in a ascending order. Okay, so we are sorting this data with the help of this order function. Okay, so now we are sorting it, and then once we have sorted it out, like you can see all the belows are first, and then all the aboves are next. Now we have to make sure that our car names variable, because we want to see which type of cars are below average, which type of cars are above average. It should be the factor type. So there are two way to convert a particular variable into the factor. Okay, although the car name is already in a factor type, but it is good practice to make sure it should be in a factor type. So either we can use the function as dot factor, or either we can use the function factor, then the name of the variable, which is the car name. Okay, and then we are mentioning the levels. So which mean this particular variable having how many values. So we are saying that it is equal to the car name. So that means every name is a unique name. Okay, that there is no repeating number. So that's why the level is going to be exactly equal to the name of the column. Okay. Now if I run this one, now we can again checking the data set. Now, in order to draw the divergent bar chart, what I am doing is I am saying ggplot, the name of the variable in which we have data set. On x-axis, we want to draw the name of the cars. On y-axis, we mention this z-score value. Okay, and then we are saying label this with the help of z-score. Okay, we are drawing the identity. Okay, that is the side by side bar chart, and then we are mentioning we are filling those bars with the help of mg types, that is below and above. Okay, so we will see the two types of bars. Okay, one is with the help of below and other is going to be above. So this fill is going to be filled with the help of these mg type. Okay, as well as we are mentioning the width of those bars, and then we are mentioning labeling those bars, that mean above average as well as below. Okay, and as well as we are also mentioning the color type. So we are saying that the above bars color should be equal to this one. So you can also mention red and green even by using the English words. Okay, so these are the just codes to represent certain colors. So this is representing with the help of below. So if I run it, and then as well as I'm saying coordinate flip. So let me run this without coordinate. Okay, so if I run this one, so as you can see, on axis we have a car names, on y axis we have mg underscore z. So if I use this one, okay, this coordinate flip. So so now you can see that on y-axis we have the name of the car because we have flipped the graph. On x-axis we have the z-scores. So this green color is indicating the name of the cars which having on average more mileage per gallon compared to these cars. Okay, so in addition to the bar chart, we can also draw the you can say dot plot. So all the things are going to be same, only the difference is instead of using bar, we can use point. Okay, the rest of the things is going to be same. So if I run it, so you can see instead of bars, there is a dot plot. Similarly, if you want to use the lollipop plot, then in addition to the point, we have to mention the segments. Okay, and in the segment, we are mentioning that the y-axis should be start from 0 and ended up to the mpg underscore z. So that means whatever the value of the z is, it should be end from that particular point. So if I run this command, so now you can see that this is the diverging lollipop plot. So starting from 0 to that z score. Okay. So I hope it's clear. So if you want to show some deviation, then you can use out of these three plots either bar chart or a diverging dot plot or a lollipop plot. Okay, now
Dr.
yeah,
Hakim, may I ask one
yeah,
question?
please, please, please.
Uh, Actually, it's not a question, it's just like a comment. First of all, regarding the context of this data, I think this data, that's empty cars, it's inherent to our studio. I mean, it's a part of our
Yes,
program, just like Iris, right?
yes, yes, exactly.
Okay, so for example, like we frequently use this data iris stats about sepal length and petal length, and I think this data can also be found in R. Okay, that's great. My second question is that we use this thing that standardized score to find out outliers. So, for instance, if anything has more than 3 standard deviation, and if there's something a value that's less than -3, so we consider it as an outlier. But we didn't consider this visualization, so I think that's a great way. We had done it in Microsoft Excel. uh, do you also use it for finding outliers, or just, I mean, although it's I can see that the objective is pretty much the same to see deviation from a center point, but Is it something that's specifically used for this purpose to find outliers? Because we know we also use some other techniques like box plot. We also use it to have an idea of
Mhm.
what are the outliers, and I think this one can also be used for that purpose.
Yeah, Z-score can be used to identify the outliers. Usually, the criteria is normally people are saying if the you have plus minus two, so that means the data points are crossing the two standard deviation or two Z-score, more than two Z-score. So that means that points are known as outliers. Some people use three Z-score, but right now the objective is different. Right now, we are using z-score to quantify the reference point, and that reference point is the zero. Okay, so we are using that z-score to quantify the reference point, and then we are drawing the graph in order to know uh, which are which cars are having more mileage per gallon from the zero. So that means from the average point, which car are covering more mileage, okay, per gallon compared to the rest of the cars. So this is basically this reference point is basically this z-score value. So that is basically zero. So if you can see from my code, uh, that is, let me show. So that's why when I'm applying if else condition, so I'm applying that if the mileage per gallon z is less than zero, so that means the referencing point is zero. Okay, so that's why I calculated the z score of every particular car. Okay, some cars having the z score more than zero, some having the negative. So that's why I considered the referencing point zero, and then whatever the car having the z score more than zero, so obviously they have the mileage per gallon above average, and whatever if it is negative, it should be the below average. Is it clear?
Yes,
Yeah.
yes, definitely, it's clear. Thank you very much.
Most welcome. Like Dr. Asif is telling us about the different type of the built-in data set in R. So you can also write down the command data and then write down bracket. If we press enter, so you will get the list of the data set which are available in the R. Okay, as you can see, air passengers. Similarly, you can see IRIS dataset. Okay, so these are the different dataset which are available. So empty car is one of them. Okay, so here we have the cars. Similarly, we have the empty cars. Okay, so these are the built-in dataset which you can check from the list, from this particular list. Okay. Okay, so the next thing we are going to discuss is basically if we are interested to check the relationship between the variables. Okay, that means if we want to know the correlation between the variables. So for that, we have three types of the plot. Either you can use scatter plot, either you can use bubble plot, or either you can use correlogram, which is also known as visualization of the correlation matrix. Okay, the scatter plot we can use whenever we have the two quantitative variable and we want to know the relationship, whether they have the positive relationship or whether they have the negative relationship between each other. Whenever you have three variables, okay, then you can use the bubble plot. Okay, as you can see in a scatter plot, we get examine anxiety variable and exam performance, and we can see that as the exam anxiety start increasing, so exam performance start decreasing, so they have the negative relationship or negative correlation with each other. So against the same data set, we have the exam anxiety on x-axis, on y-axis we have the exam performance, and the third variable I am considering is the revision time. Okay, so we know that from the scatter plot that as the exam anxiety start increasing, the exam performance is going to be decreased, which means they have the negative relationship. But we can also see that if the revision time is increases, so the exam performance is increases, as well as the anxiety level is also be decreased. Okay, so with the help of the more revision time, we can increase the performance as well as we can decrease our exam anxiety. Yes, Cologram is also known as the heat plot as well. Okay, so you can also use Cologram as a heat map as well. But heat map can also be used for other purposes as well. Okay, but whenever we have more than three or even three variables, we can use Cologram, or you can say the correlation matrix. So as you can see that for that, I am using basically the same data set of cars, empty cars. On x-axis, we have the different types of the variables, okay, and as well as on the y-axis, we have the variables, okay, like mileage per gallon, gear variable we have horsepower, weight of the car, okay, the same we have. And as you can see that these different numbers are representing the correlation between those variables, okay. The different colors are having different meaning. What are that one? Let me draw this one and then we will discuss what's the meaning of this one. Okay, first of all, what I am going to do is, in order to draw the scatter plot, I am using a data set which is the exam and anxiety. So this data set I am using, which is basically in the format of dot and DAT. Okay, so in this particular data set, we have a variable code, we have the revision time, we have exam, we have anxiety, we have gender. So first of all, I am interested in order to know if the exam anxiety having any relationship with the exam performance or not. Okay, so for that, first of all, I am reading this data set. So right now I'm using a function read.delim, and then I'm mentioning the name of the data. Okay, if the data set is in a same you can say folder in which we have the R Studio project, so then you if you there is no need to mention the exact path of your data. So you just need to write down the name of the data, and then R is going to be read that data set. So if I run this command, now we can view this data set. Okay, as you can see this one, we have code, we have revision time in hours, we have exam performance, we have anxiety level in terms of percentage, we have gender variable. And with the help of this scatter plot, we can visualize it. So how we can do that? I am saying draw a ggplot. So this is basically the structure of ggplot, which is the name of the variable in which we have data set. Okay, then on x-axis, on y-axis, then I am saying because this structure is added into a variable called scatter, then I'm saying scatter dot. I want to draw what kind of plot? That is GUM point. So point means scatter plot, and then I'm mentioning x-axis label and y-axis label. So if I run this command, okay, so now you can visualize this scatter plot, and we can easily see that exam anxiety and exam performance having a negative relationship. Okay, so if I want to add the regression line in this scatter plot, how can I do that? GUM point plus, by using the function GUM smooth, and method is LM, which is a linear method. Okay, and then I'm mentioning the color of that line, as well as I'm mentioning the standard error is equal to false. Okay, what does this mean? So if I run this command, now you can see that this is going to be showing me the regression line. Okay, and we can see that the regression line having the negative slope. Okay, so negative slope means they have the negative relationship between each other. Okay, so the standard error is going to be false, mean this ggplot is not showing us the confidence interval. So if I remove this one, mean if it is going to be true, which is by default it is. So right now I am saying GUM empty and then smooth. Now I am removing this thing. So the rest of the thing is same. Now, as you can see that this basically dark gray color is indicating the confidence interval. Okay, so by default it is 95% confident. The regression line is going to be like within this range. Okay, the next thing is if I want to see this regression line, okay, with the with different colors. So what I am doing is, in addition to this one, I'm mentioning alpha is equal to zero point 0.1 and fill red. So that this alpha is basically indicating the you can say darkness of this color. So if I am increasing this number point up to zero point 0.5, so you will see that this background red color is going to be much darker. Okay, so as you can see this one. So then fill is basically the red line of that regression line. Okay, so let me again switch to zero point 0.1. Okay, so similarly, now if I want to, can you hear me?
Yes,
Okay,
we can hear
okay. So now if I want to add the confidence interval with respect to the gender wise. So basically I want to know, is the exam anxiety and exam performance having any relationship with respect to the gender? Okay, mean male and female perspective. So if I run this command, now we can see the different lines of for the male and as well as the female. So no matter whether it's a male, whether it's a female, as an exam anxiety start increasing, the exam performance is going to be decreased. So this is, we can use the scatter plot, even we can add the regression line and the confidence interval of the regression line in order to check the relationship between the two quantitative variables. Now, if we are interested with the help of three variables, so that means we can use the bubble plot. So again, for that, again, I'm using a data set called empty cars, and I'm drawing the bubble plot with respect to weight is a quantitative variable, mileage per gallon, and the size of the bubble is with the help of horsepower. Okay, so if I run this plot, so now you can see that smaller the horsepower, the smaller the bubble size is. So larger the horsepower, so larger the bubble size is. Okay. So as we can see that the higher weight cars having the higher horsepower and having the lower mileage per gallon. Okay. Now, if I want to improve this bubble plot, mean by adding some colors. So with the help of alpha, that is basically using for darkness of the color. So we are filling with red, okay, and then adding the shape sizes, okay. So if I run this one, so now you can see that we have labels x-axis, y-axis, as well as added the title, as well as changed the color of the you can say bubble plots, okay, as well as the size. So the size of this bubble plot is going to be increased with the help of this range function from 1 to 14. So if you are going to mention from 1 to 5 or 1 to 6, the size of bubble plot is going to be reduced. Okay. So that's why for that we are using the function called scale underscore size underscore continuous. Okay, so I'm using the bubble plot for the dataset exam anxiety, which I am showing you earlier. So for that, on x-axis, I'm mentioning the exam anxiety, y-axis exam performance, the size of bubbles are going to be revision time, and then I am saying fill is equal to gender, so which means different bubbles are going to be showing the different gender. Okay. So as we can see that on x-axis we have the exam anxiety, on y-axis we have exam performance. The different size of the bubbles are indicating the revision hours, the revision times, okay, and different colors are indicating with the different genders, okay. So the interpretation is the same. As you can see that higher the revision time is going to be reduce the exam anxiety and improve the exam performance. Whereas if we are spending lower time on the revision, so the exam anxiety as it is going to be start increasing, our exam performance is going to be decrease. Okay, in most of the cases. Okay, now I am moving towards the third type of the plot in order to represent the correlations. So that is basically visualizing the correlation matrix. So in order to draw the correlation matrix, we need another package, which is basically, you can say, the extension of the ggplot2 package, which is ggcor double r plot, okay, which is basically a graph of grammar correlation plot. So first of all, we need to install it. So once we install it, we have to call this library, and I'm using again the empty cast dataset in order to draw the correlation matrix, or you can say correlogram. So now what I am doing is I am calculating the correlation matrix. So how can I calculate the correlation matrix between all the variables in the empty cars? So you call the function COR, that is basically the correlation function, and I am saying round this correlation up to 1 decimal point. So and then I am storing that correlation matrix in a variable CORR. So if I run this command, we can see that this is a correlation matrix between all the variables. Uh, I hope you know that the correlation matrix is always a symmetrical matrix. So what does that mean is, as you can see, the diagonal values is always going to be 1. Okay. So the upper matrix, the upper side of the matrix is going to be exactly equal to the lower side of the correlation matrix. So that means either you can show the upper side of the correlation, either you can show the lower side of the correlation. Both are indicating the same type of the result. Okay, so this is known as full correlation matrix. Now, in order to check whether this MPG and horsepower correlation, which is saying that the correlation between mileage per gallon and horsepower having the negative relationship, which means 80% of the time as the horsepower start increasing, the mileage per gallon is going to be decreased. Now I want to see whether this relationship is significant or not. So for that, we can calculate the p-values against this correlation matrix. How we can do that? That is cor underscore pmat, and then the name of the variable in which we have the data set. So basically we want to find out the correlation p-values matrix. So if I run this one, and then instead of writing head dot, I am mentioning p dot mat, in which we have the entire p values matrix. Okay, so as you can see that so this is the p value. Okay, this is the p value. So what's the interpretation? The interpretation of this p value is our null hypothesis is h naught rho is equal to 0, whereas alternative is rho is not equal to 0. So that means no correlation between two variables. Okay, and where this means there is a correlation between those two variables. Okay, and the decision making criteria is if the p value is going to be greater than or equal to your pre-decided alpha, which is approximately, most of the time we are considering 5%. If this condition is true, we are going to say except h naught. Okay, so that means there is no correlation between the variables. If the p value is going to be less than alpha, so then we will say reject h naught. Okay, so reject h naught means there is a correlation between the variable. So as you can see that uh, so the p value is less than 5%. So that means we can say that mpg and cyl, between these two variable, having the significant correlation. And what kind of correlation? With the help of this correlation value, we can tell that whether it's a positive or negative. So we can see that this is a negative correlation. Similarly, I can see that between mpg and horsepower, this is over here, the p value is also less than 5%. So this is, there means there is a significant correlation between mileage per gallon and horsepower, and they have the negative relationship. Okay, so I hope it's clear now how we can calculate the correlation, how we can calculate the p values. So now we are going to use this correlation matrix results as well as the p values matrix result in order to draw the correlogram. Okay, so for that, I'm calling a function from this package GGCORR plot, and I am entering the variable in which we have a correlation matrix. Okay, so if I run this one, so I can see this correlation matrix on x-axis, on y-axis we have the same set of variables. Okay, as you can see that this diagonal is basically indicating the same, which is basically 1 1 1, and you can see that so the negative correlations are going to be shown with the blue color. Okay, whereas the positive correlation it is showing in the red color. So lighter the red color is indicating the lighter the correlation between the variable, darker the red color is indicating, and the darker the blue color is indicating the high correlation. Okay, so instead, if you want to see instead of squares you want to see the circles. Okay, so then you need to add method is equal to circle. So if I run this command, now you can see instead of squares this is the circle. Now, what I'm doing is I'm applying the hierarchical clustering. What does hierarchical clustering mean? As it is going to apply the similar type of correlation, which means if the variables having the higher positive correlation, it is going to be clustered at one side. If they have the negative correlation, it is going to be clustered on the other side. So that means what is going to be happen, it is going to be rearrange these variables in a way, however we would be able to see the high correlation variables on one side and other lower is going to be on other side. Okay, so if I run this one, now you can see that they have rearranged it. Okay, so over here we can see the negative correlations cluster. Over here we can see the positive correlation cluster. Okay, similarly over here we have the positive correlation. So this graph is rearranged to this one by applying hierarchical cluster approach. Okay, now if I want to add the correlation coefficients in this particular graph, what I can do, I can add label is equal to true. The rest of the thing is going to be same. So if I run this one, so now you can see that the correlation values are going to be added in that one. Now, if I want to add the p-values, so it is not going to show us the p-value, but it will show us the cross if that the correlation between those variables are not significant. Okay, if I run this command, now you can see that some of are crossed. So that means between those two variables, there is not a significant correlation between the variables. But if it is not crossed, so that means those variables having the significant relationship between each other. Okay. So as I mentioned earlier, that the correlation matrix is always a symmetrical form. So that means either you can represent the upper triangle or either you can represent the lower triangle in order to show the correlation between all the variables. So that's why at the last I am showing type is equal to lower, or either you can mention type is equal to upper. So in order to add this one, if I run this one, now you can see that it is showing me the lower triangle and it is showing me the correlation. So I haven't added the p-value over here. So if you want to add that one, so you can just simply copy it and paste over here. It will show us apply the cross if there is no significant relationship, but if there is a relationship, it will showing us without crossing. Okay, as I told you earlier, so different color is basically indicating the different type of the correlations. Right now the red color is indicating the negative correlation, whereas the green color is indicating the positive correlation. So the lighter the green, lighter the red color is indicating that means there is low or there is no correlation between those variables. So I hope it's clear that if you want to show the relationship between the two quantitative variables, so for that we can use either scatter plot or a bubble plot or a Correlogram. Now I am moving towards if you want to show the ranking. Okay, rank the data. So for that, either we can use the type of bar chart, which is the ordered bar chart, or either we can use the Pareto chart. Okay. So for that, what I am using it, I am using a data set Pareto chart underscore CSV. So basically, if I run this data set, Uh, so we have the types of the defects and we have the counts. Okay. So we have collected this data set. Now I want to show this data set. So for this, I can use either the order bar chart or either we can use the Pareto chart. So first of all, I'm reading this data set again using read.csv because the type of the data file is CSV and I am storing into the variable called df. So we can also view this data set, and then after that I am saying this data set is going to be stored in a variable defects, and then with the help of this one what I am doing is I am saying factor df defects. That means the first variable, which is basically. So basically now we are rearranging this data set. We want to show the higher quantity must be shown first and the lower quantity after that. So for that we are going to apply factor. So that means it should be convert this one into a factor, and the level of this variable is going to be exactly equal to the defects, and then we are saying order this variable with respect to the second variable, which is count, and how it is going to be ordered, that is in a decreasing way, okay, in a descending order wise. So the larger frequency is going to be shown first and then the smaller one. So if I run this one, and then again I am using the ggplot, okay, the simple bar chart. So as we can see that this is the ordered bar chart. On x-axis we have a type of effects. On y-axis we have the counts. So similarly, we can also apply the Pareto chart for this type of the data. So for that, we need a package called GGQC, which is basically graph of grammar quality control package. Okay. So first of all, we need to install this package and then we are calling it. So for that, we have ggplot, the type of the data on axis, on y-axis, and then we are mentioning stat underscore Pareto. So if I run this one, okay, basically I'm mentioning the colors of the bars, this dot points, okay, and outline of this bars colors, okay. So this is basically the Pareto chart. How you can interpret, you can apply 80-20 rule. So that means we want to highlight the major 20% of the issues. If we are going to address those 20% issues, we would be able to solve our 80% of the problem. Okay, so this is the today's lecture regarding the ggplot2 with respect to the data visualization. So regarding this data set as well as code, you can also check my GitHub. So in this ggplot2 repository, you can find out all the data files as well as this R code. Okay, so thank you so much. So if you have any questions, so most welcome.
Thank you very much, Dr. Hakim. Yes, this ggplot is really much more informative, and these visualizations they are really beautiful compared to basic R program. Uh, I have a few
Yeah.
questions that are quite like very basic type of questions. Can you please go back to this R Studio?
Yeah, please.
Okay, can you go back to the top of this page?
Yes.
Thank you. So my question is quite a simple question. That's about opening file and importing data.
Yeah.
Normally, what we do is that we import data by using this command that you have also used. You have used this syntax, that's read.csv file dot choose and then parentheses, and then it opens a window, and then we open that. And CSV file, I think that's a very good format because it opens a window and then you can just click
Yeah.
on the file and it will open it. That's one way. And then we also use another way. For example, if our data is in Excel, then we can specify the
Yes.
path. For example, okay, drive C, and then the name of the person, and then desktop, and then file name, and then even sheet, like that. Uh, bu- but in that format where we specify the whole path, that's usually a little bit more tedious, and many time errors happen. And I find personally that the CSV file, that's much more user friendly.
Yes.
So I just want to ask you, what are the best practices, because you are an expert, so like what are the best practices that professionals use? Because even in CSV file, if you have data in Excel file, you might need to first convert it into a CSV file.
Yeah.
So what best practices professionals usually use to import data into RStudio?
Uh, People are use a different type of data. Even the text file they are importing, even SPSS file, SAS file you can import, Excel file you can import. But most of the time, even when I am analyzing the data, I also like that it should be in a CSV format. And I have seen most of the people they like CSV format because you can easily open into the Excel and you can also visualize the data. So even before importing into the R. So people mostly like the CSV. But you can import whether you have the data in a text format, as I show you uh, in a later part, that we have the data in a dart form, which is basically the text format. Okay, that is, I believe, when I was talking about the employee anxiety data set. That was on the upper
Mhm.
side. Basically, that is this one. Okay, so it's up to
Ah,
you whether it is in a DAT form or a text format or a CSV or Excel. So that doesn't matter. So whether it's in Excel, even I like that the data must be in a CSV format because I can visualize the data. I can check the data if there is any missing value even before importing into the R.
yeah. We also do the same
Yeah.
thing. I also find it more
Yes.
convenient and user
Yes.
friendly, and there are no chances, or chances of mistakes are minimized because R will automatically open a window, and then you just go to where you have your file, desktop or download, and you just double click it rather than typing or making a
Yes.
mistake. Okay, before I go to the second question, I would like to ask students that, do you have any question about this aspect? So any one of you, if you have any
Professor,
question, yeah, sure.
are you talking about an aspect of, in the sense of importing the data, or
Yes.
just what the doctor was talking about?
First of all, it's Rigo, right?
Yeah.
Yeah, Rigo, we are talking about like importing files, and I know there is like another file also. For example, I mean, on at the top on the left side, there's a file, and then you can go on file and then open that, and then you can open it. So like there are different ways. So yeah, Rigo, we are talking about opening and importing data in RStudio.
Okay.
So do you have any question about importing data set in RStudio? Okay, then my next question is about syntax we use. Let's say, for instance, if we go to this histogram syntax, can you
Yes.
please navigate to that?
Yes. 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 That is.
Thank you. That's right. So my question is that I can see, like, I mean, it's a long syntax, although it's not like really long, but I mean, once someone is doing practice, then it becomes really easier. So my question is that, is it also possible? Is there also an intuitive reading of this one? which means, for instance, if we I can say here it starts with ggplot. Okay, that makes sense. And then after parentheses employee data, that's the name of the file. And then we go to aesthetics, and then x is equal to salary, which means, okay, that's the x-axis, and then plus, and then in the next line after tab, that's theme, bw. And then, so is there like an intuitive appeal, or we can like read it in a way whereby we can also understand these commands rather than just memorizing things?
Yeah, there is no need to memorize this thing. So you can just memorize this particular portion. Like in order to draw the histogram or any type of the chart, so once we call the function ggplot, then we write down the variable in which we have the data set. So if you can see that, so we are calling a function ggplot, and then I am
Mhm.
mentioning the name of the variable in which we have a data. Okay, this is the
Okay.
first thing. The second thing, we have to mention the aesthetics. So which mean we are mentioning x-axis, y-axis, if you want to tell the type of line or the size of the line or the coloring perspective. So that is basically the AES function, which is aesthetics. Okay, so this is x-axis, y-axis, right? So once we
Uh-huh.
done this, so basically we have created a structure of the graph, right? We call the data, we created the x-axis as well as the y-axis. Then by adding this plus means we want to add some extra objects. Okay, so what kind of object I am adding? I am adding theme underscore BW, which is theme black and white. Okay, so which is basically I am adding this particular thing, which is basically this one. Okay,
Mhm.
this one. So as I told you earlier, that these three things are compulsory in order to draw any type of chart. So till now in our command, we have mentioned the data, we have mentioned the statics. Now we are adding a command theme, and then I am adding the type of plot, which is the histogram. Okay, that is the third component, which is the geometric object, the type of the plot. So even uh, this is not compulsory that you have to mention this theme over here. I can rearrange it, I can mention the type of the plot, and then I can mention the theme. Okay, even with the help of this one, we can able to draw the histogram. So basically, this is the name of the variable in which we have data, we have statics, we have the type of plot. Okay, and
Okay.
then we are mentioning the extra objects which we want to add, whether we want to add the theme, whether we want to deal with the coordinates, whether we want to deal with some statistics, whether we want to show in a smaller plots, which is the facets, which is small or larger perspective. So that we can add in addition to that. Okay, so that is basically we are adding as well as labeling. So as you can see that actually in this plot we have basically added four things. One is the data. We have added
Mhm.
the statics, mean x-axis, y-axis. We have tell the type of the plot. Okay, so even
Mhm.
if I am not doing anything else, okay, if I run this command, you will draw the, you can see the histogram. Now,
Mhm.
with the help of this plus sign, and I am adding the theme. So basically, I am changing the theme of background theme, that is black and white. Okay, and then I am labeling it. So what should be on y-axis, what should be on x-axis, what should be the title of the plot. So if we run it, so now we can see that on x-axis, on y-axis, and the title. Okay, so
Okay.
for every ggplot2 plot, so you have to see the graph with respect to this one. As I mentioned earlier, these three things are compulsory for in order to draw a graph using ggplot. So you can add some factors or you can add some objects with the help of statistics, coordinates, theme. okay, depending upon what you want to do with the graph. Okay, whether you want to add some statistics such as mean, standard deviation, error bars, confidence intervals. Okay, whether you want to see the graph horizontally or vertically, you can use the coordinate. Okay, as we have seen, flip coordinates. Whether you want to see the graph in two parts. Okay, I want to see the histogram of female separately and the male's salary separately, so I can use the facets object. Okay, if I want to add the theme, which means the background of the bars graph, then we can use the theme object. So I hope it's clear now.
Yeah, thank you very much. Students, do you have any question about this aspect, please? Okay, one question, last question from my side. I can see that this arrangement, this pattern, it follows throughout.
Yes.
Oh, I see. One student has raised hand. Please go ahead.
Oh, I just wanted to ask, in a lot of these, like, does the order matter? I guess.
No, order is not matter. Okay, as I show you earlier, even I can show the theme before the histogram. Okay, I mean the type of the plot. Uh, Now, if I run this one, even I can see the histogram. Even if I adding this theme after the plot type of plot, so then it is also okay. But remember that first, the most important thing is that is the data type. That means the variable in which we have the data set, as well as the statics. This is important. First of all, you have to mention this one. This component is compulsory, the first one. After that, you can rearrange. It is up to you, whatever you want to show.
Okay, thank you.
Most welcome.
Thank you. Yeah, I think that was a great question about a sequence and does this order matters. And I can see that the same pattern also follows in other command. For instance, let's say when we go to Boxplot, we will also see like a similar type of thing. For instance, let's say uh, is can you please like tell us like in this Boxplot, this options, what is this first line?
Yeah, like this one is, as mentioned earlier, especially you can use this command in any, you can say, statistical results or in any graph. If the graph results are shown in a scientific notation, such as 1.3 point e bar something. Okay, so if the results are shown in a scientific notation and you want that it shouldn't be showed in a scientific notation, it should be showed in a decimal points, okay, or a whole numbers, then in order to remove those scientific notation, you can use this options scipin is equal to 999. So with the help of this command, the graph is going to be shown in either whole numbers or the decimal places instead of showing the result in a scientific notation. Okay, so no, because I have already run this particular command, that's why it is showing me on y-axis the whole numbers. But once you close this file and before running this particular command, if you run this ggplot2, you will see that on y-axis the graph is going to be shown on a scientific notation. If I go back, maybe I will find it. Let me go back. No, I have enough, I think.
Okay, but I can see like for instance, if we have like some normal type of data does not has a large number, maybe like in 7 digits or 8 digits, would we still need this one? Can we run this box plot even without
Yes,
these
yes, yes,
options?
yes. Without this option, we can run this one. So even if I am not,
Okay. Oh,
so this is just on a y-axis. If we have the data set in a scientific notation, and we do not want that it should be shown on a scientific notation, we just want to show the results in you can say decimals or in a whole numbers, then you have to use this command. But even in order to draw the box plot, even you are if you are not using this command, even you can draw the box plot. So for box plot, what we need ggplot, and then name of the variable in which we have the data, which is our employer data, and then I am mentioning the variable against we are drawing the box plot, which is a salary variable, and then I am mentioning the theme. Even if I am not mentioning this theme, I am just mentioning the type of the plot, which is a box plot. If I run this one, so you can see that this is the box plot. Now I am adding a theme. Okay, basically that is the background, which is basically the background which is going to be black and white. Okay.
And when we add colors to this one.
Yeah, now you can add as many things as possible. Like as I'm adding over here, this is the
I
type
see.
of the variable in which we have data on x-axis. We are saying it shows us the, because I want to draw a box plot for male salary separately, for female salary separately. So that's why I'm mentioning on x-axis gender, on y-axis there should be a salary. So now I'm adding a theme because I want to, the theme should be the black and white. Now I'm adding the type of the plot, which is a box plot. Now I'm adding some statistics. So what kind of statistics? I want to show the median point in the box plot. I'm telling that that median point is going to be shown in a point. Okay, and I'm mentioning the size of that point, and as well as I'm mentioning the color of that point, okay, which is red.
Mhm.
And then I am labeling that plot. What is going to be y-axis, what is going to be x-axis, and what should be the title of the plot. So now if I run it, so now you can see that this red color is basically with the help of this particular command, this red dot. Okay, so this red dot is
Okay.
the median point, okay, having the size to having the color red.
Mhm.
Okay.
Okay. One last question. This concerns your earlier point that was about scientific notations.
Mhm.
For instance, let's say when we conduct some correlation test or a regression test, and then we get a correlation value and regression value, and we always get p-value.
Mhm.
And many time p-value, that's probability values, they are usually very small, and they are expressed in scientific notation. So although that's not an issue, I mean, we can always rename.
Yeah.
But I was just wondering, like, is there also a way to show that output in a way whereby they do not appear in a scientific way, whereby, for instance, we can show all those
Yeah,
zeros?
yeah, yeah. By adding this command before that command,
Hmm.
okay. So
I
before
see.
running that particular command, if you add this particular command and then run that command, you will get the answer in decimals or in a whole numbers.
Oh, that's
Yeah,
great.
yeah.
Because I know many time we have like these values.
In a scientific.
I mean, especially in terms of
Yes,
correlation and
yes,
regression. That's the one we use, and a probability value especially. Okay. Oh, that's great.
yes.
Okay. Any other question from student side? Okay. Dr. Hakim, thank you very much. Now, if for instance our student they want to go further, I have already shared with them this RStudio file. I have already shared with them a CSV file, and this video will also be available to them. If they want some like a further guidance, I know you are like running a YouTube channel, and that's very famous, and you are really an
Yeah.
expert. So can you please like refer us to, I mean, if someone needs further guidance and where they should go?
Yeah, even I will upload this recording on my channel as well. So you can go to my YouTube channel with my name. Okay, as well as on my YouTube channel, if you people are interested in order to uh, get some correlation and regression analysis using R, So you can click on these links, as well as for regression analysis, for testing of hypothesis. Okay. If you are interested in Python, you can go for Python perspective, the data visualization and the descriptive analysis. This is the predictive analytics using Python, as well as this is the prescriptive analytics playlist. So if you are interested, so you can go over there and you can check those playlists.
Okay, that's good. Thank you. Just for information of our students, Dr. Hakeem, he would also be giving one more lecture to us about statistical quality control. He's also an expert of Six Sigma. He's a Six Sigma black belt, and Six Sigma is like one of the hot topic, which means that's about a reduction of wastage and a minimization of defects. But that lecture will be given to another class, that's quality management. So if any of you are interested, please let me know. I will share that information with you. Thank you very much, Dr. Hakim. It was so nice to hear from you.
Thank you.
I already knew about this thing that GGPLOT is more informative. It gives visualizations that are very beautiful compared to base R program. Today we had an opportunity to see all these things firsthand. Let me see. I see there are some comments. Okay. Okay, that's about YouTube channel. Okay, thank you very much, and we will see you soon in another class that will be about Six Sigma, about application of statistical quality control tools and techniques in improving quality management.
Sure, sure.